Hey friends, Azure Virtual Network NAT, NAT means Network Address Translation, it simplifies outbound only internet connectivity for your virtual networks. Christian Kutz is here to show me how to use a NAT gateway to simplify that outbound connectivity today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. I'm here with Christian Kutz, and we're going to talk about NAT gateways for virtual networks. How are you, sir?
I'm doing great.
So I'm always interested in things that I realize may be a problem, but I never thought this was a problem. I've been making outbound calls from my resources in Azure for years. Why have I not bumped into the problem that this is a solution for?
Usually customers that don't make very many outbound connections or go to lots of different places to make the outbound connections on the, lots of different places on the internet don't run into the problem. But there are customers who've experienced the pain of running out of connectivity effectively. And it's kind of ugly when it happens because all you see is that your TCP connections just don't work and you don't know why.
Mm-hmm. And this is not Azure doesn't have enough of some physical resource things. These are fundamental TCP and IP things and how networking and in the world of limited IP addresses works, right?
Yes. This is very, very low in the stack and usually not something you can see from an application perspective.
So when I make an outbound connection from one of my resources right now, is it just working automagically and this is now going to put me into more control?
Yes. So today there are several different options. There's about 4 or 5 different ways to create outbound connectivity. They all have their trade-offs. They generally either just kind of work until you hit the limit, or they're very difficult to set up because they require a lot of planning, a lot of monitoring, and you kind of have to keep up with it. And that was one of the main reasons why we built this feature.
Okay, so this is kind of hard to talk about. Let's see if we can visualize it. Maybe you can show me what this looks like.
Yeah, let me share my screen here real quick. So if we start out with a basic network where you may have some VMs, some scale sets, and of course, those are deployed into a subnet. You may also have a subnet with app service, for example, where you might host a website or something else. And when you have deployed this, you really usually don't think about how you talk to things outside of your virtual network. Your virtual network is private until you deploy a load balancer or something like that. You don't actually are able to get into the network. And outbound sort of happens automatically, but sometimes there's problems with which IP address is used. So if you wanted to talk to something that is an API somewhere in the public internet, maybe you have to tell them what address you came from. And that can be very difficult. And some services haven't offered that either. And then there are some challenges around scaling the service. So that's why we came up with this NAT gateway resource. But this is sort of the basic scenario. And what happens under the covers that you haven't probably directly observed is that your private addresses, so in this graphic, it's the 192.168 address space, has to be translated to a public IP, which in this case is this 2069.128.127 address. And the way that's done is as a application on a virtual machine creates a connection, so it tries to build a TCP connection. It is then translated to this public IP address, the source addresses, the destination stuff stays intact, and it picks a port that is associated with that address. So this is the translation that takes place. And you probably have never noticed this unless you've actually really had problems or really paid attention to this part. So as more virtual machines make connections, they get additional ports assigned, and there's a finite number of ports that is available.
And there's 65,500 and something 68 ports,
so
right?
It's 65,535.
Yeah.
can't use the first 1024 because they're privileged ports.
Right.
And so you end up with 64,500 and change.
And this is one of those things where that's a huge number until it's totally not enough, and it's an incredibly small number.
And if you don't design your application correctly, so if you don't reuse connections, do sort of pipelining, or you just have a lot of connections to the same place, you can burn through 64,000 ports in a hurry. And it does happen. But in reality, actually, because of the way things work in Azure up to this point, you actually never really have 64,000 ports to play with unless your virtual machine has a public IP directly assigned to it. And some people don't like that. So you actually get less than that. Some services, it's 1,024 ports per virtual machine. Sometimes it can be less. And when that virtual machine's bucket of ports is empty, your connections just fail. Okay. And they don't fail as a refused connection, they just kind of time out.
All right.
So when this translation happens, this is to show that if there's some other VM that tries to create a connection, they all sort of get mapped to the same thing. That's in general how this stuff works. And so I want to show you a quick demo of how to take this scenario on the left, where a VM has a public IP, and change it to a scenario where we use a NAT gateway. And so all these different VMs that you might have on your subnet don't use their individual IPs anymore for outbound connections. They use the ones that are on the NAT gateway. So hang on, I got to switch around here a little bit. So I'm going to go to, there we go. I'm going to go to a virtual machine that I have already built in WestUS 2. So this is just a plain VM that is deployed there, Linux VM. And I have created a service that is tells me what the IP address was that I came from and what port I used. So this is sort of the SNAT translation in action that we can observe with this. And in this case, the VM just has a public IP. So it has full access to all the ports that are associated with this IP address. So in this case, the VM probably picked 36478 as the source port, and that's what you see on the outside. So if I keep doing this, you can kind of see that every connection just gets another port, and this has to do with how the specific operating system picks the source port. Linux and Windows are a little bit different, but in general, this is what happens. So now I have this VM sort of running here. It's continues on making connections, and you can see that it's just incrementing until eventually starts to wrap around. So let's go to the portal. This is actually the resource group that is deployed. You can see there's just a virtual network. The VM has a public IP. There's an NSG on there, so I can get to the machine. There is an IP address and a prefix that I've already created. And there's, of course, the VM itself. So let's add a NAT gateway to this. So you just go here.
Software-defined networking just blows me away.
Yeah, this is something that's bolted very deeply into the software-defined networking stack in Azure, and is provided by Azure as a service for customers. So you don't have to operate this. You just go here and you create it. You can specify an availability zone. I'm not using one right now, but you could. So this is the first step. So this is all you configure. You can change the idle timeout up to 2 hours. So the default TCP idle timeout for connections can be accommodated by going to 2 hours. But you should choose this as low as you actually need it, because it does have an impact on what the scale of your deployment is, not what Azure's scale is, but just how the mechanics work. So now what next thing we need to do is we need to pick a public IP. And in this case, I'm just going to pick the one I've already created. And I happen to have a prefix that is a /30, so that is 4 addresses. I'm going to pick that one as well and add it.
Just as an aside, is the world running out of IPv4s, or did we solve that problem with things like NAT?
Yes. So primarily, this is a problem in IPv4 address space. and IPv6, it does not tend to be an issue because customers just use ubiquitous IPv6 address space. There are translations between v4 and v6 that we could do with this, but we don't have that available today.
Okay.
So I'm going to pick this VNet that I have, that I want this to be associated with it. And when I say I want to connect this, what happens is the subnet is reconfigured to send all outbound traffic to the internet through the NAT gateway. But you don't have to create a route. So there's no user-defined routes to play with or anything like that. This is intended to be just about as simple as you can get by just, you tell each subnet which NAT gateway you want to use, and Azure does the rest. So this has succeeded. This took a few seconds. The portal still, there you go. And if I go back to my VM now, this will take a couple seconds for the SDN stack to catch up with the fact that we have completely reconfigured things under the covers.
Wow. And it's still going, and it's just going to wake up and things are going to change.
Yes. In fact, my SSH session that I used to get in this VM is completely not impacted, even though actually underneath there's a lot of stuff happening. So now I see that one connection that got caught in the middle until the NAT gateway is attached. And now I can see I'm going through all sorts of IP addresses that I've associated with this NAT gateway. There's this prefix in there. You can kind of see there's a whole bunch of addresses that are right next to each other. So that makes whitelisting really nice. And yeah, this is basic. This is as simple as it is. You create it, you give it an IP address. You could change the timeout if you want. You can use the default for most things just fine. And this is how simple it is. But what this does is it solves a lot of problems. So let's talk about that a little bit more.
Mm-hmm.
So just quick.
Before you say, so if this is something that I add, should everyone do this, or like when do I know that it's time? And I don't want to get in over my head, but I want to be prepared. And I like that you actually had the application running, and then you solved this problem, and the application kept running. So that was very comforting. It doesn't seem like it's going to be like anything other than a good fix. But I don't want to do this unless I need it. There's going to be a class of person who's watching this show, and they're going to say, "Oh my goodness, that's been solved," and they're going to hit pause and they're going to go and be excited about this and set this up.
Yes. So if you have maybe 1 or 2 VMs or something fairly small, this is maybe not the thing for you. Mm-hmm. But let's say you have scale sets. You have resources that, like a scale set that automatically changes its size, or you have tons of different things in the same subnet, and you don't want to go and touch every one of those things to tell them how many ports they have, which IP address they should use, all those kind of things. And if you're trying to say everything that's on this subnet or all the subnets in this VNet should use this address space, that's one reason why you should do this. If you use the app service v3 preview that has been around for a few weeks, I think, or a month, you can also use a NAT gateway with that service. And then the NAT gateway will provide you with a dedicated IP address and actually give you higher scale than was possible before.
Nice.
So, this was designed to be very, very simple. Mm-hmm. And simple in the context that very large scenarios created lots of scaling problems in the past, and were also very difficult to manage because you had to allocate something, then you had to go check if the allocation was sufficient.
Mhm.
If you didn't do that, you would create yourself a service outage for your application. And that happened. And this is one way to try to get rid of that problem.
Well, my last question before we go back and see how you would configure this using an ARM template is there a person out there who may be watching this who has this problem and doesn't realize it? And what kind of characteristics would their website or their application or their compute be showcasing? What kind of behaviors or unwanted behaviors would they be getting? Might someone be having flaky outbound internet and not realizing that it's in fact port exhaustion?
Yeah, so because this is so far down the TCP stack, an application really doesn't see this directly. It can't tell what happened. It just something went wrong.
Mm-hmm.
And because this is an exhaustion scenario, what happens is the existing stuff that we've had as tools in Azure hasn't been able to tell you that there aren't enough ports. So you would try to create a connection, and then that connection would just time out. Or worse yet, your scenario was intermittently broken because it looked like you had high latency, because you tried to make a connection, the port wasn't available. Now some port came available in whatever you had allocated, and all of a sudden it starts working again, and then it stops working again because you're sort of bumping against the ceiling. And that happened primarily because these ports are allocated per VM, and they're not shared across the subnet. So if you had one machine that ran really hot for this for some reason, because maybe it's some API gateway or whatever, it didn't matter that there were still ports left on these other VMs that weren't being used. There's nothing you could do.
Yeah.
And the way NAT gateways work is they share all the ports from all the IP addresses, so up to 1 million SNAP ports is what you can configure today. And whatever VM needs them at what point in time gets the port, and the moment it's no longer used, it gets reclaimed, and you can, some other VM can then use it when it needs to.
Very cool. So let's see this ARM template, because it's simpler than I would have expected.
Yes, so ARM templates can be very, very complex, and keeping with the theme of keep this simple, the resource is done the same way. So really all you set up on a normal basis is you tell it what IP addresses you want it to use. Maybe you change the timeout. If you have availability zone scenarios, then maybe you want to pin this NAT gateway to a specific zone to create isolation. But that's it. There's nothing else to do. There's on the NAT gateway itself, there's no additional configuration. And then when you want to use it somewhere, you go to the virtual network and you tell the subnet which NAT gateway to use. You don't have to go set up a route, no UDRs required, any of that sort of stuff. We do all that stuff for you. So this is really a very, very simple way to do it, and the recommended way of creating outbound connectivity if this is something that applies to a scenario.
Well, that seems very clean and very simple. In fact, like I said, a lot more. Once I understand the problem and understand that I might have that problem, it seems like it's pretty straightforward. Like you said, it's been designed to abstract the problem away from you very nicely.
Yeah, and what we could do is we could go through some of the other options that customers have today that sort of have been around for a while. Some of these things have been around for a few years, some of them much longer than that. So this this graphic is intended to describe this per VM allocation. That's sort of these buckets with the green dots and the blue dots. The blue dots represent the SNAP ports that I've given to a given machine. So that might be, say, 4 VMs in this picture. And then there's a graphic underneath that that's intended to say how hot this outbound connectivity is in demand on the specific resource. And so the first bucket had 9 ports, and it's running really hot. There isn't anything else to give because this is a fixed pre-allocation. The second VM uses 3 out of 9, and it doesn't matter that it's only using 3. The first VM is not going to get those ports that aren't in use, and so forth. So this has been this way in Azure for pretty much the very beginning. And sometimes you see this as load balance for Sometimes if you use a cloud service, this happens automatically underneath the service for you. So you may be completely unaware, but this is how the service works. And so if the first virtual machine wanted to make more connections, they'll start failing, and they fail as timeouts, very invisible. And so when we compare this with NAT gateways, everything is on demand. There's no pre-allocation, so you don't have to plan for what a specific VM wants to do. You set up what the entire scenario wants to do, and then you create enough IP addresses for scale. And again, as in the left scenario we just went through, in the right scenario, the VM that needs more ports just gets them, as long as there's ports overall available for the NAT gateway. So this actually, if you have workloads where it's very unpredictable what the specific load is on a VM, this can be a very useful tool because you don't have to plan for the worst case. And it's very, very simple.
This is a lot of information and a lot of stuff to absorb, and I feel like you've done a really great job of compressing that into a short amount of time. But if I want to learn more, if I want to dig deeper into this, if I'm listening to this show, where can I go?
Yeah, so here's a set of URLs that you can go to. You can obviously go to the documentation site, but if you want to write these short names down, that might be really useful. There's a description of how the service works, how the resource is constructed, and a design guide for different scenarios. There is a fairly extensive debugging page that also provides design suggestions for things you should do or shouldn't do, and different scenarios that happen in these NAT exhaust scenarios and how you get around them. So this is very useful. It also tells you what the metrics are, of course. And if you have suggestions or things that we aren't doing today that you want us to do, please go to user voice and add your voice to that so we know about it and we can let you know when we deliver it. And lastly, if you, for some reason, you want to reach out to the whole team, send an email to natfeedback@microsoft.com.
And a real human is on the other side of that email address.
Yes.
This is the great thing about Azure. You're one of them. That's fantastic.
The whole dev team reads this, so
that makes me happy.
Yes.
One of the things that I like about Azure and I like about Azure Friday is the reminder that actual humans are out there trying to help you with your business and with your the things that you're trying to build on Azure. So I appreciate that. And I appreciate you coming by to share this with me, Christian.
Yeah. Thank you for giving me the time here to tell the world about it.
All right. I am learning all about NAT gateways for virtual networks today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.